9.5, building off of what we did on Friday with trig. We're just adding on to our trig because so far with trigonometry, all we've done is worked with solving for side lengths. But trig talks about the relationship between angles and sides of a right triangle. So it doesn't just work with sides, it also works with angles. But in order to do that, in the situation where you have something like tangent of A equal to, say, I don't know, 2/3, you have to be able to get at the trig ratio itself. You have to be able to, get rid of the trig ratio itself. In other words, you have to be able to move tangent, cosine, or sine without touching the angle. Now, tangent of A is a function. It is not a multiplication. It is much like things like where you have x squared or you have the square root of x or various other things where in order to get rid of the thing happening to x, you have to do its specific opposite operation. Trig's opposite operation is actually known as inverse trig or inverse trigonometry. Now, inverse trig just looks like your trig ratios with like a little -1 symbol, almost like in an exponent place, but it's not an exponent. On your calculator, find your sine, cosine, and tangent buttons. They're generally in the middle of the calculator somewhere. Now I want you to look right above them. Do you notice the one with the little -1 next to them, each of them? Those are the inverse trig buttons. So to get to an inverse trig button, you literally just have to hit either your second key or your shift key, and then your typical trig button. So one thing you might be asked to do, because I'm tight, is to evaluate trig. Evaluate the following, round your answer to the nearest degree, because inverse trig solves for angles, so it's always going to be in degree when you use inverse trig. If I want to do sine inverse, I hit the second button, I hit the sine button. It gives me the sine with the little -1. Now on my TI, it does not open a set of, it does open a set of parentheses. On my Casio, it does not. When you're doing it of just a plain number, it doesn't matter. 0.4848. On the TI, I should close it. On a Casio, if I don't close the parentheses because there wasn't an open parentheses, that's good. If you put an open parentheses, it's not necessary at that point. Rounded to the nearest degree means round to the nearest whole. Nearest whole number? 29 degrees. Next one's cosine inverse of 3/4. So, second, cosine. 3. Now, some calculators throw a hissy fit if you use the fraction bar. The fraction bar is just a divide symbol, so use a divide symbol. 4. On my TI, I close my parentheses. Now, my calculators are doing two different things this time. My TI gave me a number, my Casio threw a hissy fit. Here's why. If you do not have the parentheses here, what this is doing is it's doing cosine inverse of 3, trying to evaluate that, and then dividing it by 4. Cosine inverse or trig inverse doesn't always work of all numbers. You need the parentheses when this is anything other than just a plain number. So I need parentheses here. So on my Casios, I have to do cosine inverse parenthesis 3 divided by 4, close parenthesis, and then it gives me the same thing as my TI. To the nearest degree, 41. What is tangent inverse of 8/3? Yep, heard a couple people say it is. 69 degrees. Did anyone not get those numbers? Because if your calculator is in the wrong mode, you will get all of these things wrong, so we need to make sure it's in the right mode. Scroll down, and we want degrees. There, click enter. Now if I clear out, and click enter again. Move over, and click enter. Now if you click clear, it'll get you out of here, and that would work. If there anyone else, the calculator is not saying the right thing. If you didn't check your calculator, please check it. Especially if you use one of my calculators. My calculators get used in my FST class as well. My FST stands for Function Statistics and Trigonometry. They do a lot of trig, and they will switch back and forth on units. Everyone's good? Okay. So, now, evaluating inverse trig, really, really easy. You type in the calculator exactly what it says, add parentheses if necessary. Sometimes I'll give you a trig equation, or a trig ratio if you were. It wants me to solve for the measure of the angle. The angle is the thing right here. In this case, it's L, here it's A, here it's W. If I want to solve for something, that means get it alone. In other words, I have sine of L right here. I need to get rid of sine. In order to get rid of something, you do its opposite operation. What did we say sine's opposite operation was? Opposite of sine was the sine inverse. Inverse trig goes in front of things. So I take sine inverse of the entire left side of the equation. If I do something to one side of the equation, you do it to the other as well. So I do the sine inverse of the entire right half of the equation. Now on the left side of my equation, I have sine inverse of sine. What do opposite operations do to one another? Cancel. Death to them both. We're left with L. L equals sine inverse of the square root of 5 over 7. L is alone. What do you think we're going to do now? Simplify by typing it into our calculator. Technically, it's evaluate, not simplify. Simplify would imply I'm getting exact things. Do I need the parentheses? Yes, I absolutely need those parentheses. Sine inverse, square root of 5 divided by 7, close the parentheses, open parentheses, square root of 5 divided by 7, close parentheses, and my calculator's give me two different answers. Which one's right? The Casio this time is, because on a TI, whether it be the new TI or the older TI, they always, when you put a square root symbol, try to group things with your square root. In other words, what I typed in here was this. Where's the problem? Sorry, you can't see it. The 7's not in the square root, so make sure that after your square root of 5, after the 5 you put a close parenthesis, then divide by 7 and close parenthesis it again. If you got the newer TI, make sure that when you type it in, you get out of your square root before you divide by 7. Either way, what should it round to? Nearest degree, 19 degrees. Try out B and C. screen. You see nothing. Okay, I'm going to do these out of order. If I want to get W alone here, what am I going to do? Because it's being stuck inside of tangent. What's the opposite? The little -1, it's tangent inverse. I put that in front of things, and you're often going to see me do this. I save myself writing out that full step by just doing this and making sure it's in front of things. What's happening over here? Cancel out the tangent and the tangent inverse, leaving me with W. On this side, I still have tangent inverse of 19.081. Sorry, 0811. What am I doing with this side? Put in the calculator. What do you get? 86 point a bunch of 9, so 80. 7 degrees. Oops, I didn't mean to turn that off. The reason I did this out of order is because of how I wrote things on here. Because that's hard to write over. And I wrote things on that. Okay, same idea here. The only difference is now, in order to get A alone, what am I doing? Cosine inverse, or the inverse of the cosine. Gone, type into my calculator. A is 43. Don't forget the degrees. Okay. Trig inverse, a much harder step than what we were doing on Friday already? Not really. So, the hardest part of working with trig and trig inverse is, one, typing it into a calculator, but probably the bigger issue is just making sure you're doing the right thing, because they're going to be mixed in. Now, this first page is all trig inverse, but sometimes they're going to be different. Now, that being said, you're also going to end up with a situation where most of the time I'm going to give you a triangle. I'm not going to give you the equation. You have to write the equation. But to write the equation, you do the same things we did on Friday. So, I'm going to want to find the indicated measure. I don't know why I zoomed in on this one. I'm going to wait on that, actually. Indicated measure here is the measure of angle P. When doing trig, you always want to focus in on one of the acute angles. You either know the acute angle or you're looking for the acute angle. In this case, we're looking for it. The angle I'm looking for is P. That's my focus angle. That is my angle I use to identify my opposite, my adjacent, and my hypotenuse. Which side is the opposite? The vertical, the horizontal, or the diagonal? The vertical. Because it's across the triangle. That's the opposite. Eli, why are we on the computer? Oh, okay. Maybe not the best time, but yeah, that's okay. Just make sure you're getting caught up on stuff. Okay, which side's the adjacent? 13. Which side's the hypotenuse then is? This one. Do you notice the opposite doesn't have anything marked on it? It's not helpful. It's technically the opposite, but it's not helpful. Adjacent and hypotenuse are helpful. What's that memory tool again? TOA, how do I spell it? It's almost like it was written behind me. Okay. Adjacent and hypotenuse is which of my 3 trig ratios? The ca one, so cosine. What immediately follows the trig? The angle, in this case P. If I knew it as a number, I'd put the number. I don't, so I put the letter. Equals, the adjacent is 13, the hypotenuse is 19, and it's adjacent divided by hypotenuse, so 13 divided by 19. You write your trig ratio. My variable's here. Cosine needs to go to get rid of cosine. Inverse trig. Inverse cosine specifically. I do it the lazy way and write it like this. Always goes in front of things. I'm left with P on that side. On this side I have cosine inverse of 13/19. I type it into my calculator. Round it to the nearest degree. I thought it was, but I'm going off of memory. Yeah, 47, you right. And it's an angle, so I put degrees. Okay. Problem B. What angle am I going to focus in on? Why D? What it tells you to solve for. 16, is it the opposite, the adjacent, or the hypotenuse? Opposite because it goes across the triangle from the angle that we're focused in on. How about that 23? Hypotenuse, because it's the longest, it's across from the right angle. This is the adjacent, but is it helpful? No. Opposite and hypotenuse is what trig ratio? It's the so part, and so tells me to use sine. If you forget what letters it is, it's if only it was on your calculator. Oh, wait. Immediately after trig is always the angle. In this case, D. Is it 16 over 23 or 23 over 16?
16 over 23.
Sine is opposite divided by hypotenuse, so 16 divided by 23. I want to get D alone. Inverse sine. Both sides. Technically, this side cancels out. D equals sine inverse of 16 23rds. I heard two different answers. On to the nearest degree. That one, by the way. 44. Try out C on your own. Isn't labeled, right? It's not helpful. So you got adjacent and opposite to work with. Which trig ratio do you suppose to? Yes, because it's got the O and the A. So when we start with T, just tangent. So tan. Following that is O. I don't generally jump to that. Eventually you will be able to do that. So if you want to start to tangent inverse right away, you can. Opposite or adjacent. Trig ratio first, second. Trig ratio top, bottom. Okay, which angle are we focusing in on this one? B. Why? It's the one we're trying to solve for, which means 22 is the opposite. 19 is the adjacent. What trig ratio uses opposite and adjacent? Tangent. Tangent of what? Equals what over what? To get B alone, what do I do? Inverse tangent. So B will be inverse tangent of 22 over 19. And tangent inverse of 22/19 gives me what? 49 degrees. Yes.
Why is the 22 on top of the 19?
Because it's opposite over adjacent. Because TOA, the first letter, tells us which trig ratio. O tells us which one goes on top. A tells us, or the third letter tells us which one goes on bottom. So tangent is always opposite divided by adjacent. And it was the opposite because B is what we focused on. If you did it the other way around, you accidentally solved for angle A, which you should have gotten 41 degrees, but this one should be 49. Now there's one more problem on this page, and then on the next page we start to mix things together a little bit. What's the angle of focus? B. Which side's the opposite?
9.
So it goes across. Adjacent?
12.
Hypotenuse?
15.
Hypotenuse is always across from the right angle. Angle of focus is always one of the acute angles. Either you know this acute angle or you're trying to solve for this acute angle. And you go across from it to get that opposite. Now, do you notice that you know opposite, adjacent, and hypotenuse here? Which means you can use any trig ratio you want. Which one you choose really doesn't matter. I make the choice based on which side length I want to avoid. Now, these ones all look just as easy as one another, but if one of them involved a square root, you'd avoid it. If one of them involved a decimal, you'd avoid it. In this one, you just got to make a choice. Which side length do you not want to use? Hypotenuse, sure. It's the first thing I heard. So if I'm going to ignore the hypotenuse, I've got opposite and adjacent. O and A are TOA or tangent. Tangent of
BB.
the angle, in this case B, equals 9 over 12 or 12 over 9?
9 over 12.
Opposite divided by adjacent. Tangent inverse both sides. And we end up with 37 degrees, I believe. Now, if you had done the other trig ratios, so this one, tangent inverse of 9/12 gave me that, which rounded to 37. Sine would have been sine inverse of 9/15. Cosine would be cosine inverse of 12/15. Get the exact same thing. If you don't get the exact same thing, that's a problem. Okay. As I mentioned earlier, the hardest part of trigonometry is actually mixing all of the things together. So, we're going to find the value of the variables. We're going to round angles to the nearest degree and sides to the nearest hundredth, which means now it's not only just trig inverse. Trig inverse solves for angles, but sometimes we're solving for sides. First thing you do is still that angle of focus. In this case, which angle makes sense as the angle of focus? The one you're trying to solve for. That's the variable, x. Meaning 4 is the opposite. 7 is the adjacent. Square root of 65 is the hypotenuse. If I know all three sides and I'm doing trig, I avoid one of the sides. Which one looks good to avoid? Hypotenuse. Okay, my memory tricks. So, TOA. Adjacent and opposite goes O and A. TOA, in other words, tangent. Followed immediately by what? The variable, in this case x, because it's the angle. 7 over 4 or 4 over 7? 4 over 7, because it's opposite divided by adjacent. To get x alone, because the x is right here, I'm doing tangent inverse. Dead. X equals tangent inverse of 4/7. Tangent inverse of 4/7 happens to be 30. When rounded, it's 30 degrees. Problem B. What's your angle of focus? X is what I'm looking for. Means this is the opposite. But I don't know it, so it's not helpful. I don't know anything about it. This is the adjacent. I don't know anything about it, so it's not helpful. This is the hypotenuse. Is there a trig ratio that just works with the hypotenuse? No. Is having multiple things that I don't know going to be helpful? No. So having an angle I don't know and a side length I don't know is not helpful. Which means I can't use trig to solve this. Ellie, what are you thinking? What do you know about the angles? It's a triangle. Don't angles of a triangle always add up to 180? Do I need to use trig at all? No. If I know two angles and I'm looking for the third, just use the fact that angles add up to 180. You don't need opposite, adjacent, hypotenuse. You just say x is whatever 180 minus the 90 I know minus the 51 I know is. It's 39 degrees. Problem C. Do you notice this time you're solving for a side length? Which means inverse trig is not going to be involved, but that doesn't mean regular trig won't be. What is your angle of focus? Angle of focus is always the acute angle you either know or want to know. If you're not trying to solve for an acute angle, it's the one you know. So this is my angle of focus because it's an acute angle that I know. Never focus on the 90. It's not helpful. It won't do you any good. 12. Opposite, adjacent, or hypotenuse? Opposite because it goes across. X. Hypotenuse. It's across from the 90. Opposite and hypotenuse. Sine. Sine of 42. Trig of the angle equals, the fraction is 12 over x. Now, how do I solve for the variable when the variable's in the fraction? Get rid of the fraction by multiplying by its denominator. Always the bottom of the fraction. I don't care if it's a letter or a number. Multiply by the bottom of the fraction. In this case, x. Does that x get multiplied by the 42? No, it gets multiplied by the sine of 42, and sine of 42 is a number. So I've got x getting multiplied by this number equal to 12. If x is being multiplied by something, how do I get x alone? Divide by the number, which is sine of 42. It's not a pretty number, but it is a number. That goes away. X is whatever 12 divided by sine of 42 is. Now it's not pretty, but it types into the calculator beautifully. 12, divide symbol, sine 42. Close the parentheses. Now, this is a side length, so we're rounding to the nearest hundredth. How many decimal places? 2. 17.93. Okay, problem D. Solving for a side length. What's my angle of focus? It's hard to know, right? Because you're not solving for an angle, so you don't want to choose an angle you don't know. But the only angle you know is the right angle. Can't use the right angle, though. Can't use trig on this. But here's the thing. In situations where you know two of something and are looking for the third one, there are other tools you can use. Like this one was angles of a triangle add up to 180. Now sides do not, But what's the relationship between 3 side lengths of a right triangle? There's a theorem, it starts with a P. Pythagorean theorem. A squared plus B squared equals C squared. Sound familiar? Which of those variables am I picky about what I put into it? C. C needs to be what? Hypotenuse. Which side's the hypotenuse? The 5. So the 5 squared goes on that one. The other 2 are just the other 2 squared. I'll do x squared and 4 squared. I square things first. 4 squared is 16. 5 squared is 25. If I want to get x squared alone, subtract 16. X squared equals 9. To get rid of a squared, I take the square root. Now, this is a side length, so I round to the nearest hundredth. Now this one's nice, it's 3. If it's not nice, that's okay. You don't have to simplify the square root anymore, you just type it into a calculator and evaluate it. Round to the nearest hundredth if necessary. So Pythagorean theorem still comes out. Okay. Final 2 problems. Problem E, what's our angle of focus? 60 degrees. X is the opposite. 11 is the adjacent. What trig ratio? Tangent. Tangent of 60 equals opposite over adjacent, x over 11. When the variable is in the fraction, I always solve the same way. Multiply by what? The denominator, in this case 11. Do I multiply the 11 and the 60? No. I have 11 getting multiplied by tangent of 60. It's equal to x right now. I need to get x alone. Done. Type it into the calculator. Rounded to the nearest side length, hundredth, 19.05. So keep an eye on what you are rounding for. Try out the last one on your own. Once you have that, which give me a second because I'm going through and solving it too so that the recording has it. Let me take a look at what you got. And I will give you the worksheet.